This is the video that I promised about the Bowden tubes and the couplings. So what I'm going to do here, hi new people, by the way, if you want to skip over any of the review stuff, there's always a time index in the video description so you can click around in the video. When I originally filmed all of this, it wasn't as systematic as it's going to come out in this video. I did do it systematically, but what happened was there was a big oops moment in the middle that made me kind of have to redo the whole thing, and as a result it became very non-linear. So I'm going to cut that little part and stick it at the beginning, take the little beginning part, stick it at the end, and hopefully this makes sense as some kind of like narrative. What this was all really about was using a particular type of coupling that I haven't seen used elsewhere, that I've been wanting to try for a while, and I ordered these months ago and just kind of sat on them. And for some reason I got it, I don't remember why because I lost those videos, but for some reason I got it in my head to try it just a couple weeks ago, and well, these are the results. And I will be getting back to the fan cooling videos that were previously promised. Like I said, some of that just got scrambled as far as the footage and the times have got screwed up. But I do have still some interesting videos that I pulled out from that and quite a bit of work still that I have to do. But it's coming. During the time that all of my stuff was a mess, I only had what I call the wall computer to work with, which is essentially all the parts I have lying around just smushed together in a machine, and it can barely run CAD, and I can barely get like, you know, Cura running on it. But I figured I could do something fairly simple and not waste a whole lot of time just sitting around twiddling my thumbs. So this will be a good opportunity to talk about minimizing Bowden backlash. I figured I would just try out some like premium components, see how premium they actually were, and try some rather unorthodox or at least stuff that I hadn't seen before just to see how well it actually did. Then I could just dump all that footage and worry about it later. Not a lot of computer horsepower required in that. But the whole thing kind of chose its own direction when halfway through I came to the realization that there's such a thing as counterfeit Capricorn tubing. I think, unless they changed the specifications over time and I just got some of the like really old stuff with larger internal diameter and crappier Teflon and all that kind of stuff. If that's the case, somebody let me know in the comments. I didn't see anything on their page. And spoiler alert, this stuff was unusable, so I have a hard time believing that this ever would have been sold as premium tubing. But regardless, I already had some genuine Capricorn tubing, but I only had 2 meters of it, and I knew that I was going to be destroying some with some testing, and I wanted some spares. But traditionally, I don't or didn't, whatever, use Capricorn tubing because of certain physical properties of the tubing itself. But long story short, I ordered Capricorn tubing by the foot from this place, like a couple meters of it, and got some bad stuff. And I don't think they're aware, so I'll be letting them know soon. But as a public service announcement, I thought I would put this out, and I'll show you how to spot the bad stuff and what it looks like when you print with the bad stuff. And I'll put that in context of the larger experiment where I actually do compare the slop in the Bowden couplings and the slop in the Bowden tubings and do it as if it were legit and I didn't run into those problems anyway. Before anybody asks, this is the current setup for this printer. It's ever changing because I'm in the middle of a series, so this is just a snapshot in time of what's going on during this video. The firmware currently on it is the Marlin 2.0.3. The settings are all stock but uncapped, so I am not artificially limiting the acceleration to 500 millimeters second a second, that type of thing. So I can set those in a slicer as opposed to them being set on the EEPROM or the firmware. And there are no slicer tricks involved, as in when I went through, I used the stock Cura profile for this printer, but I turned off anything like additional wipe and combing and those types of things. If I may be so bold as to assume that everyone watching this video already knows what a Bowden versus directorized system, that'll save us a lot of time. And I'm not going to start a flame war between the two systems. They both have their pluses and minuses, but with the Bowden system, you're always going to have a little bit of extra travel. And I'm just going to refer to that additional bit of retraction as necessary as Bowden slop. The 3 main areas you have to look at are the couplings themselves, the clearance, which is the clearance of the inside of the Bowden tube, as in the space between the inner diameter of the Bowden tube and the outer diameter of the filament itself as it runs through the Bowden tube, and then the physical properties of the material the Bowden tube is made out of itself, also with respect to the geometry of the cross-section of the Bowden tube, and its properties with respect to the properties of whatever it is you're printing. I know that's a lot of words, but it'll make sense in the future. So, couplings first. This is what the slop looks like in a coupling after a few months of printing. I'll show you why that's worn out there, but this is what the slop looks like in brand new couplings that just happen to kind of be crappy. In both cases, you have an additional couple millimeters of play. 4.2 millimeters of play, actually, I know because I measured it. But your measurements will vary depending on the amount of wear on your tubing and the relative level of crapitude of your couplings. The stock Cura profile for the Ender 3 assumes like 6.5 millimeters of retraction, which I was only using like 4.7, even with the stuff was worn out, so if you're all the way up at that length, oy. But let's take a look at what these things are, and then if we break it down, that'll help us understand where the problems are coming in and maybe present a solution for us. As you may have guessed, these were just repurposed from another industry. These are 4mm push-in quick-release pneumatic couplings. Some key characteristics of pneumatic control systems are that they tend to be lower pressure, single-way, compressible medium systems, i.e. air. That's all important because it informs the characteristics of the couplings that we've borrowed for this purpose. I destroyed this pneumatic coupling for your benefit to show you what's going on with the retention mechanism in here. As you can see, there's these little triangular teeth inside. As you push the Bowden tube into there, you can't pull it out because it acts like a barb. If you press the little blue, usually blue, tab down, it compresses those barbs and lets you remove the tube. And there are many different places you can go online to check out things here, as in this article that was written on e3d.com about the various Bowden clips and tubes and slop and things like that. So I'll just touch on the relevant parts to this immediate discussion. But the problem is, with any barbed system, it's really only good in one direction. You can have, like we do in these Bowden systems, a stop at the end where we have the end of our tubing, it butts against the one thing, and then we have the barbs on the other. The problem is we only have the mechanical properties of the Teflon tubing itself and the barbs that are sinking into them to keep that rigid. So once that tubing starts to wear out at the contact point between the metal and the Teflon, you start to get slop. Or if you just have bad tubing that doesn't have, bad couplings that don't have sharp teeth, then you just have slop naturally. Now, you most certainly can get pretty decent couplers, and if you swap out your tubing and couplers all the time, you can keep it pretty good. For example, right here, you can see the difference on the left between the worn out coupler and the right with a brand new coupler. And I'm well aware that there's no end to the possible solutions online that you can try to fix this. I just want to see if there was something that worked a little better that we could repurpose. Enter the hydraulic coupling. The medium used in hydraulic control systems, well, the hydraulics, much less compressible, much more precise, much higher pressure, and more dependable. That's why we trust them every day in things like, well, our brake systems. Problem is that it's a bit harder to get parts in the right size. It's also a more complex system and takes a lot more effort, but I knew I could get the coupling slop to absolute zero, so I figured I'd give it a whirl. So these are the parts you'll find in your typical hydraulic coupling. It's 4 parts. You have the stationary collar, you have the compressive collar, and in the middle you have 2 things. One is typically called the olive, and that's this little compression bushing right here. And then this is typically called the barb, which goes inside your tubing. So in a perfect world, we could just slip the compression collar over top of our tubing and then slip the olive over top of that. You stick the barb into the end of the tubing, and that's to give it something to compress against, to seal the hydraulic fluid in, and to keep the tubing from crushing. And then you put that into, well, your stationary collar at the end, then secure it to whatever it is you're trying to secure it to. The problem is the type and dimensions of the tubing that we need to use for 3D printers is not what these are meant for. So we're going to have to shave down the diameter of the insides a little bit, and then when we stick this barb into the end of our Bowden, we're gonna have to shave down the outsides of the Bowden a little bit, because otherwise we're not gonna be able to slip our olive over top of that. Cool? Now, this was just really a proof of concept, so I'll rush through here. Basically, what I did was clamp it into a little pony vise and then just use various size drill bits to ream out the parts that I needed to and clamp it together. If you want a how-to on this, I could do that as well. I just don't want to waste the time in this video doing it. So was it a pain in the butt? Yes. But did it do what I thought it would do? Yes. It brought the slop in the coupling down to 0. And that means I had a setup that I could accurately test premium replacement tubing against the stock tubing that we have been using. Now, as I hinted at in the previous video, the goal that I more or less arbitrarily set for myself was about 2 millimeters of retraction. So I wanted to see how close I could get to that, or if I could surpass it with various modifications. Because this printer, oh mine, which will probably be decommissioned soon, runs at 1.5 millimeters retraction and has a Bowden system, obviously. So as far as our ender, this is basically the stock settings plus 2 millimeters retraction and the stock Bowden setup with the little clippy John and the zip ties. So yeah, plenty of room for improvement. So, time to take premium tubing and add it to the hydraulic coupling and see what kind of a difference it makes. And it did make a big difference. Unfortunately, that was a bad big difference. Yeah, like I said before, freaking nightmare, and this is where this segment of the journey begins. The journey from Capricorn to Crapricorn. And that pissed me off because I already had some fake Capricorn, which was, tubing that was supposed to have the same specifications as Capricorn, but was, from AliExpress or whatever. So I thought maybe I mixed the two up. But the thing is, I knew the fake Capricorn was black because I purposely ordered it black so I wouldn't mix it up, and it came in this envelope with this adorable certificate of authenticity. So I didn't mix them up, meaning it was this genuine, in quotes, Capricorn by the foot that was causing this problem. So let's look at what that problem is. Now, my reaction, as is the reaction with most people that don't have narcissistic personality disorder, was, oh my god, what did I do wrong? So I did a couple more prints and checked in to see what was going on, see if there was movement in the couplings, because I had never tried this before. I thought maybe I just screwed something up or misunderestimated something else. That's when I noticed this. Did you catch it? All right, here we go. We're going to have it again. There it is. Every time we went from a retraction to a print move, we would be stretching the Bowden tube out, and you could see that as it dove. Now, full disclosure, that's the reason that I'd stayed away from premium Bowden tubing in the past, because of that extra stretch that it tended to have. But I had heard that Capricorn's newer formulation was stiffer, so I was going to give it a try. But, this amount of stretch was kind of ridiculous. So if we go back to just the standard white Teflon tubing, you can see that even here between the retraction and the print move, there's not a whole lot of compression going on with the Bowden tube. There's always going to be a little for reasons that I'll explain. Stick around till the final ending if you're interested in all that stuff. But that told me that we had fake Capricorn tubing. And we know that because even though we don't have all the physical characteristics of all the tubing we're using, we have at least some of the characteristics of the Capricorn tubing on their website. So we can use that as the basis for a little bit of math and show what's going on here. And no video would be complete without an unnecessarily dangerous experiment to go along with it. So yeah, we're going to test those tubings as well. Those tubings? That tubings? Whatever. Now, the specific property I'm interested in here is the Young's modulus, and for an exact definition, you can look it up on Wikipedia, but basically it's the ability of a particular object or substance to resist change in dimensions. Essentially, in layman's terms, how stiff it is. And they give a Young's modulus in 0.53 gigapascals for the particular formulation that they use. So we're printing PLA here, polylactic acid, which is among the least compressible the filaments that you typically find on a desktop 3D printer. It has like a Young's modulus around like 3.5 or so, give or take. But on the left here, we have the cross-section of the filament, and on the right here, we have a cross-section of the Bowden tube. So we have approximately 1.75 diameter on the left, and on the right we have approximately 4 millimeters diameter, and then we have a hole in it 1.9 millimeters diameter. So we have a cross-sectional area of 2.41 versus 9.91. But even at 4 times the cross-sectional area for our Bowden tube versus our filament, we're still talking about 3.5 gigapascals versus 0.53 gigapascals. So if these two are playing tug of war, the PLA is gonna win, but not by a whole lot. But simple fact is, with this stuff, we have a lot of weaving and bobbing going on. We have retractions and the advancing that we didn't have with even the cheapo tubing that came with it. So yeah, a go, no-go litmus test type thing is fine, but that's only any good once you have it on the machine. Visually, just looking at these two, the fake stuff was ever so slightly darker than the real stuff that came out of the real package directly from the hands of Capricorn themselves. But moreover, I could see with my own meat eyes that not only was the hole in the middle not centered on the fake stuff, which is the stuff at the top that has a coupling attached to it, but it was also a larger diameter than the real stuff. So I thought, well, let's go ahead and take some exact measurements of these things and see if they fall within the specs that Capricorn says they're supposed to. And no, they did not. They didn't even make an attempt to match the physical measurement specifications. So that means, I mean, they definitely didn't try to match the formulation specifications, the physical specifications of the actual material itself. So it's pretty easy to spot the stuff just by taking a pair of calipers to it. So yeah, 15 minutes in, there's your public service announcement. If you're selling this stuff or using it and you got it in bulk, make sure you just go ahead and check that with a pair of calipers. Make sure it's legit. And speaking of legit, I pulled the legit stuff out of the package, made myself another harness with yet another hydraulic coupling, got that all shaved down and installed on the machine and tried again. I even hung a little tag above it saying real so I wouldn't screw these up. I printed out the same model with the same setting so I can get an AB, and much to my delight, it was absolutely freaking perfect. Well, maybe not absolutely freaking perfect. It had 3 little wispies on it, as you can see right here. But compared to the hellscape that was the last one, yeah, pretty much perfect. The next experiment was just to take the same deal, 2mm retraction, and instead of using the quiet fans, use the turbo fans with the same shroud, just to see if I can get rid of those wispies. And it did. So here's a little before and after. This is the exact same setup, hydraulic coupling, all that stuff, but on the left right here, we have the Capricorn tubing, and on the right here, the fake Capricorn tubing. Real stuff, fake stuff. Now, anecdotal evidence based on results is fine, but real world data is more useful. So let me go ahead and show you the experiment that I set up, and then I'll give you the data for all the different tubes. First off, there were 5 different types of tubing, and they were all cut to 350mm in length. Then I took these eye hooks, these are just number 4 eye hooks, and screwed those into each of the ends. And it's a little tough to screw it in, but they go in pretty well, and those are freaking in there. Like, they are super hard to pull out. So after driving those all the way in, I hung one side from, well, this guitar hanger that I already had on my wall here, and then the other side I had just a regular old pull scale that went up to 50 pounds, but I only needed it up to 20 or 25 pounds or so. Before each of the tests, I took a 5-pound weight and I dangled it from each Bowden tube before I started for a couple minutes, just to make sure that everything was settled in and nothing was, slipping or going weird or any of that kind of stuff. I marked the end of it, then I pulled it down to 20 pounds, let it go, and then marked a space right up here at, 10, which was my 0, and then yanked it slowly down to 20 pounds to see how far that mark would deflect. And after running each test 3 times, here's an average of all 3 tests. So the real Capricorn tubing excess stuff was actually the best, which I was delighted to see because that hasn't always been the case as far as stretch was concerned. I started worrying about Bowden stretch years ago when René Girac started doing some tests with his dice printer on Bowden tubing and found that the Capricorn stuff at the time had a whole lot of stretch to it, and he just used the plain white stuff. So I was just using the plain white stuff because I found the same thing with the fancy tubing back in the day, so I figured, why spend more? And the absolute worst was the fake Capricorn XS that gave me all that freaking stringing. I was actually really surprised to see how well that black AliExpress stuff did, but that was 1.9mm inner diameter. I mean, you could see all that in the screenshot that I put up. But regardless, it does make my life easier that the actual Capricorn stuff is the stiffest stuff these days because, well, you always know where to go to get it. And now most of you will probably not ever be stretching this stuff to 20 pounds, but it is theoretically possible. 20 pounds is around like 9 kilograms, I think, something like that, which is like the upper bounds of what most of the really powerful extruders will do. But if you are doing high-speed printing, you can conceivably get the pressure up that high if you have like really good feeders and a really stiff motor. And if that is the case, then it is theoretically possible that that fake Capricorn tubing will be stretching as much as 17mm, which seems absolutely ridiculous, but those were the answers I got. I'm going to show you in the next section what all these different sets of tubing looks like. You can feel free to, this is a very skippable section if you don't feel like watching that. This is the fake like Capricorn TL stuff. it wasn't posing as Capricorn, it was just posing as like high quality blue Bowden tubing on like AliExpress. This stuff is just the regular old like 4mm outer diameter, 2mm inner diameter pneumatic tubing that you can get freaking anywhere. This stuff, this is the black stuff that I mentioned that was the, it has the same like specifications and tolerances as the XS Capricorn tubing, and it was actually pretty nice. I'll show you how this prints in a little bit. And then I had this stuff, which was the, you know, the counterfeit crap that ruined my day. So this next section is after I got the settings dialed in, I swapped amongst each of these different types of tubes and then showed you what the results were. So this is not by any means all of the different test prints that I did, but it should give you enough of an idea that you can get the correlation between the amount of stretch in the tubing as well as the manufacturing tolerance and the size of the inner diameter of the Bowden. But this section also is demonstrational, not informational, so also skippable. So for all these tests, here are the specs, same as at the beginning, except for the turbo fans instead of the quiet fans. And we just used the stock Cura Ender 3 profile with, like I said, the tricks turned off, but with only 2mm of retraction, higher travel acceleration, faster non-print moves, and then a faster retraction speed and a slower retraction prime. And I'll talk about that a little bit in the nerdy section at the end. Just so you don't forget what we're up against, this was the bog standard setup that I had been printing with since the day I put this thing together, but with 2mm of retraction. So for comparison, this was the best setup right here. This was the genuine XS tubing with the hydraulic coupling. For comparison, here's the tightest of the Bowden clips. This was the one that came with the Ender with the clippy jaw, and this is brand new, so it's nice and sharp. Brand new XS tubing, and this is comparison to the exact same tubing, but with the hydraulic coupling. Now here, let me show you the plain old white tubing, and this is brand new plain old white tubing, by the way. And notice here that when we have retraction moves, we don't have any stretching of the Bowden tube like we did with that fake Capricorn tubing. But regardless, the results were still pretty piss poor. I mean, relative to the premium tubing, probably just because of the larger internal diameter, but probably also because it was a little bit more flexible. But a pleasant surprise I got was this black tubing off of AliExpress with a little happy not happy mail-in card here, or whatever this is. This stuff actually had very little compression on the advance and retract. It printed out really nice. I mean, you can see it has a couple of like little genuine stringing plus the wisping. See, there's a little nubbin on the side there. But yeah, I was pleasantly surprised. And then like this rando spool of AliExpress like fake TL grade tubing. This just the regular 4mm outer diameter, 2mm inner diameter. Actually printed out pretty nice. I think it's a little bit stiffer than the standard PTFE, and maybe it has slightly tighter tolerances. I'm not sure, but it did print out a little bit better than the plain old white stuff. Here's some other random comparisons I'll throw in here just because I had them, so just feel free to skip around here. On the left, we have what it prints like with the blue clippy thing and the zip tie removed, and on the right, that's what it printed like with the exact same coupling, but with the zip tie and the clippy thing installed, so you can see the difference in stringing there. And that was just with standard white Bowden tubing. And I can't find this complete after picture of just the standard cheapy Bowden tubing with the hydraulic coupling on it. I do have this picture of it, or this video of it printing. If you're really morbidly curious about it, I could rerun that test and post the results somewhere, but it was just kind of like, you know, in between where you would expect it to be. So yeah, I actually shot out a whole bunch of footage of these different tests. I didn't make a matrix and do every possible combination of like tubing and ends because, well, quite frankly, I just didn't have enough hydraulic ends. But if you really need to see the results of some of the tests or an A/B, just let me know in the comments if I missed something important that's gonna like win you a bet on Reddit or some crap, and maybe I can get that for you. So if you just came to check out what was going on with the couplers and what was going on with the Bowden tubing, that's cool. You can tune out now, no hard feelings. This next session is going to talk about the Bowden Flex and some of the physical properties that are going on there and how that affects printing and may affect our settings. So let's look at the system of the filament and the Bowden tube. Treat both of those two things as one system when we are advancing and when we are retracting. So the reason I went through all of this math earlier was to show that one of these two members, we will call these two different parts in a system members. So we have a tension member and a compression member, and they trade off with each other. So one of these two members' mechanical properties, as in the properties of the material itself, is going to be dominating the system. And even with the higher cross-sectional area of the Bowden tube with respect to the diameter of the filament, its tensile modulus is so much lower that the PLA is still going to dominate the system. Now, of course, your filament and your Bowden tubing material is going to fall within a range, and that's going to vary. But assuming that the 0.53 was correct, and if my math was correct, for a 1.75 millimeter diameter filament, that would require a tensile modulus of 2 gigapascals before you would trade hands from the filament being the dominant member to the Bowden tubing being the dominant member, which consequently is right around the tensile modulus of ABS plastic. So let's talk about the two elements in our system. We have the Bowden tubing, and then we have our filament that runs through it. One of these is going to be the compression member, and one of these is going to be held in tension. Now, it's difficult to visualize that separately, so let's picture them two separate members apart from each other. What happens when you feed in filament? Well, you are putting compression on that filament as it tries to squirt it through the nozzle, which means since you have a stop at both ends of the Bowden tubing, you are stretching or tensioning that Bowden tubing. So if this is a bow and arrow, the bow is the filament and the string is actually the tubing. Now, get used to hearing these two terms if you've never heard them before. Stress and strain. That's what's going to be used to define all of our different physical parameters of properties, and you're going to hear me use it a million times if you sub to this channel. Stress is the pressure and strain is the distance. So let's make an imaginary curve as we're putting stress on something. So we'll say this is stretching our Bowden tube out. What happens when you release that? Well, in an ideal world, it would just follow the exact same path at the exact same rate of speed backwards. But that's not the fantasy world that we live in at all. Very rarely do you get something that follows the exact same speed and path back. Usually what happens is you have a little bit of lag, and that lag is a memory effect that we call hysteresis. Basically, that means whenever you relieve pressure on your printer, you are not relieving pressure at the rate that you say you are in your slicer, because we have a system lag. We have a memory effect in our Bowden tubing that's being stretched to tension by our filament, and that's going to dominate the behavior of the system, at least in as much as we are waiting for it to catch up. And I'm going to show you how slow that is exactly. So I set up this system here with the Capricorn XS tubing, put it under tension just like everything else, but constrained this a little bit so that it could only move up and down. And what I have right here is a 5-pound weight hung off it, and then I'm just going to pull it down and release it and let it spring back. And then we will watch how long it takes to spring back into the exact same position that it was. However, whatever that is lagged behind whatever you would expect it to be, well, that's our hysteresis, that's our memory effect, that's the lag in the system. See that? It's like a rubber band. It doesn't bounce back like a spring. It happens very gradually. Release, and then it happens over a matter of a few seconds. So first I'll show you this in slow motion, then I'll show it to you in full speed, and I'll put a flash before it and after it so you can even time it yourself if you want. But what I'm doing is pulling back this filament 5 millimeters and then releasing it and seeing how long it takes to go back to its original shape. Release. And this is 25% speed. So you can see how quickly it goes through the first part of the travel, and then it takes forever to slurp back to shape. Here's real speed. So what it looks like to me, as far as I can tell, right here we're deflected 5 millimeters down. When it's released in the first 150 milliseconds, it shoots up 3.5 millimeters or so. Then in the next 100 and some milliseconds, it goes up 1 more millimeter, and then it takes the better part of a second or a second and a half for it to go all the way back to its original shape. So what does that tell us? Well, it tells us that whatever it is we put into our slicer, as far as our, our retraction and our prime settings, they're going to be dominated by the tubing if you have a whole lot of flex in your Bowden tube. And visually, we know what the end result of that is. So this is not only because we need extra distance due to the stretch of the tube when it's being tensioned by the filament being driven into the hot end, but also on the moves in the opposite direction, we are not only pulling that away from pulling the filament away from the hot end, but then we are waiting for the Bowden tube to then catch up and retension the system and reach a stasis. Now, let me give you 5 seconds of this and I'll explain what's going on here. That was a print that I showed way early back in the beginning of this channel, a few years ago on this experimental high-speed miniature Bowden machine. You can go back and watch the whole dumb print if you're a very boring person. It was really just there as evidence for the haters. But the point of that whole exercise was to try to find out when we're pushing the envelopes of like speed and acceleration, that type of thing, what requires a kind of rethinking, or what is it that we overlook that we should be looking at, just so that we kind of incorporate that into our paradigm and then, well, hopefully get better, faster prints or better settings or whatever. But what I did learn with the high speed stuff, especially with like smaller or more intricate objects, is that you want your Bowden tube to have the least amount of flex as possible. A, to avoid having to do all that retraction, but B, because that memory effect means you're going to be into a printing move by the time that your Bowden tube stabilizes, and you're going to get in areas with under and over extrusion. And one last area that I would love to cover in this video, but I'm not, because it's going way too long, is that printing fast, and hard retractions and prime moves with your printer when you get into like super high speed stuff makes you start to really respect the non-Newtonian nature of molten thermoplastic. I mean, despite the fact that we're relieving pressure on the nozzle during retraction moves, really what we're doing with advanced moves and printing moves is that there's shear thinning going on, depending on the thermoplastic that we're printing, depending on the temperature, depending on the pressure and the velocity we're applying that pressure. We do have shear thinning and then shear thickening when we do a retraction move that prevents the filament from oozing out. But I said too much, so I'm finished with this video now. That's it. Bye. I'm going to stop talking. See you later. Support the channel. Click like and subscribe and visit the Patreon and all that heavy horse crap. Bye.